In this video, we are going to talk about a little bit of cards. Now, know anything in this class, I'm not going to require you to know anything about poker hands and what beats what. They just make good examples on things to count. But don't worry, if we ever have a problem, they should do a pretty good job explaining what we're looking for. If not, you can always email me and let me know. If it's during a test, I make sure it's very well defined of what we're looking for, and I usually give a few examples to really kind of make sure it's clear. So for this one, how many different flush hands are there? So what a flush means is that they are all the cards are the same suit. So if you remember, if you need to, go back and look at the notes from a previous section where I had the picture of all the different cards. So what that means is a suit is the hearts. That totally didn't want to happen. Hearts, diamonds, clubs, or spades. Right? Those are the four suits. Now, the next thing we're also going to make an assumption, anytime we're talking about poker, we're going to be playing with 5 cards, 5-card draw, five card stud, which means that the person is just dealt 5 cards, and that's it. There's no trading, there's no wilds, there's no anything like that. It's just you get dealt 5 cards and you're done. If the problem wants something different, it will have to state it in the directions. Okay? So, for this problem, the question is how many different flush hands are there? And this is just here, this notation here is just for people who understand poker and know poker, who may be saying, well, a royal flush or a straight flush, those are better than just a regular flush. Well, we're just going to include all of them. We're just saying flush, any kind of flush. So what we're saying is they all have to have the same suit. So all hearts, all diamonds, all clubs, or all spades, and we're getting dealt 5 cards. All right? So now, the next thing it's very important to know about poker is the order in which the cards are dealt to you is unimportant. Okay, you just get the cards, you look at the cards, and you say, did it meet this qualification? Did it not meet this qualification? All right, so therefore, that kind of yells at you. We are not dealing with a permutation. This is a combination, right? And so if the order mattered, the problem would have to tell you. It would have to specifically say, and the order, blah, blah, blah. All right, so this one is a combination. So here we go. How many different ways are there for me to be dealt 5 cards where order does not matter, and but we are going to get a flush? Well, as we talked about in the previous problems, I always say take care of your condition first. Well, what is one of our condition here? Well, I would argue our condition is let's guarantee a flush. Let's guarantee we're going to get the suit. So decisions and choices. When we're giving a flush, what is the first decision we need to pick? What suit are we going to give them? Well, how many suits are there? There are 4, and out of those 4, we're going to choose one of them. The order in which we choose it is not important. That's why it's a combination, not a permutation. So we pick, excuse me, boop, there we go. First we pick the suit. Okay, now what? We got the suit. So, and sometimes this helps students and teachers as problems get harder. I help visualize. I say, okay, what have we done so far? I have my 5 cards. I have chosen the suit. And let's pretend I chose that they are all diamonds. That is the world's worst diamond, but whatever. Okay. Diamond, 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 diamond. Okay. Do I know what the card is? If you imagine you're whispering to somebody, I'm totally rigging the deck, and I'm going to cheat, and I'm going to guarantee you get a flush. You're going to get all diamonds. Okay. Is that all the information we need to fill in these cards? No, we still need to know what are the actual cards. Is it a 2? Is it a 7? Is it a 12? Right? So now we have to take care of the denomination. That is the next decision that we need to make. Well, how many denominations are there for us to choose from? And if you remember from when we saw the deck in the previous section, it was ace, 2, 3, 4, so on and so forth, up to jack, queen, king. So there was a total of 13 different denominations. So out of our 13 denominations, we already know they're all diamonds. So out of the 13 different diamond cards, we are going to have to choose 5 of them. Right? We're going to have to choose which 5 of these are we going to stick on it. This one will be a jack, maybe this one will be an ace, this one will be a 4, a 7, and a 6. Now, is the order in which I fill them out important? Because if it is, then that changes how I do this. And we already said order is not important. So it's just 13 combinations, 5. there you go. So that is the number of ways to get a flush. There you go. So again, 4 combinations, 1, that's just 4. 13 combinations, 5. Yeah, got no idea. Oh, this computer, I switched computers for speed, and this one doesn't have a calculator on it. So let me pause, and I'll bring up the calculator. There we go. I got from my handy-dandy calculator of doing 13 combinations 5, I got 1,287. So therefore, our final answer would be that times 4, which would just be 5,148. So what that means is there are 5,148 different ways of me to create a set of 5 cards that is a flush that all have the same suit. So it could be diamonds, it could be hearts, it could be clubs, it could be spades, and it could have any groupings of those different denominations, but no repeats because there's only one of each in the deck. All right, so let's try another card problem. How many different two of a kinds? So what that means, 2 of a kind, means same denomination, obviously different suit, because I can't have, like if this was a 4 and this is a 4, I can't have 2 diamonds because there's only one of each in the deck. So therefore one would have to be a diamond and maybe the other one is a heart. So 4 diamonds, 4 hearts. Then I have 3 other cards. Now this one, I'm going to do this problem where we're going to say these are not allowed to be pairs. These are not allowed to be another 2 of a kind. Like I can't have a 5 and a 5 because then I wouldn't have a 2 of a kind. I would have 2 of a kinds, which is called 2 pair and whatever. So, and also none of these can be another 4 because now I won't have a 2 of a kind anymore. Now I'd have a 3 of a kind. Okay. And the problems, I would be very specific in writing that out. I figured since it's notes, I can walk you through it. Okay. So a 2 of a kind and then 3 other different cards. They can't be the same and they can't be the whatever number I picked over here. Okay, if you want to try it, pause the video. All right, here we go. Take care of your conditions first. Let's guarantee the 2 of a kind for let's guarantee the 2 of a kind first. First things first. When I'm doing my 2 of a kind, I have to make a decision about what number, maybe this is how I would see it, what number are they going to be? What denomination are they going to be? So I have 13 different denominations, and I need to pick 1, not 2, just one of them, because they're the same. So if I say that this one's a 7, then I know this one has to be a 7. If I said this one's an 8, then the other one has to be an 8. I only have to pick one denomination. But now that I've chosen the denomination, and let's just pretend I chose the denomination of 7, now I need to pick the suits. Right? Now the order is not important, but so therefore it's a combination, and out of my 4 suits, I need to choose how many of them. If you said 2, that is correct, because I need to pick 1 for this one and another one. Wow, diamonds are not happening today. There we go. Hearts and diamonds, let's say, or hearts and, wow, that's an ugly club. Okay, hearts and clubs. Whatever the case, I have to pick 2 different suits, and the order does not matter if it's not different if this is the diamond and this is the heart, or vice versa. So I just, out of my 4, choose 2. All right. That takes care of, now this takes care of these cards. I've chosen the denomination and I fill it in a 7. I chose the suits, and let's say that this one is a diamond. Whoop. Wow, or a cat's head. I don't know, whatever that turned out to be. Diamond. All right, that's whatever. And then the other one will be a heart. Alrighty, now I still have 3 other cards to do, don't I? Now I need to pick denominations for these, right? And here's the fun part. Whatever this denomination is, it has to be different from the next one. And whatever this one is, it has to be different than the next one. Here's the problem. If I do them one at a time, then I'm ordering it. If I do one at a time and I'm saying, okay, I used my 7s for this one, so now I'm going to use 12 for this, 12 choose one of these, 12 denominations choose one of those, then 11 choose one, then 10 choose one. Look at that. That's 12 times 11 times 10. That's literally permutations. So the trick to this is whenever there's a tie, whenever I have a 1 and a 1 and a 1, you do them all at the same time. So what we're going to do is we're going to say, all right, I'm going to pick all of these at the same time. So how many denominations do I have to choose from? I hope you said there are 12 remaining, because we already used one of them for our pair, which is correct. And of those 12 denominations, how many different ones do I need? I need 3 of them. Right? This one will be an 8, this one will be a 7. Nope, can't be a 7. 6, and this one will be a jack. Okay, so now I have picked my denominations. And the order in which I put the 8, the 6, and the jack is unimportant. If it went 6, 8, jack, same thing. And that's why we have to do them at the same time. Because the ordering turns out it makes it you're telling me that a 6-8 jack would be different than an 8-6 jack, which isn't true. So there we go. So we do our 12 denominations, choose 3. What do we still need to do? We need to pick our suits. Now these we get to do one at a time because we're going to pick the suit for the 8. So the suit out of the 4 different suits, we're going to choose one of those. Then we're going to pick our suit for the 6, and out of the 4, we're going to choose one of those. And then we're going to, for the jack, out of the 4, we're going to choose one of those. Or if you wanted to, you recognize this is just 4 choose 1 times 4 choose 1 times 4 choose 1. So we could just write this as 4 choose 1 cubed. You'll see that going a lot. And so now we're ready to go. So let's see what this comes out to be. 13 times 4 combinations 2. What is 4 combinations 2? I'm doing that off screen. I apologize for not having the calculator on this computer. I think it's 6. Yay, it's 6. Okay, 4 combinations 2. Now we need to do 12 combinations 3. And hopefully you're typing in your calculator too. I don't know. 220. Who knew that off the top of their head? All right. So now we have 13 times 6 times 220 times 4 cubed. Oh, goodness. And this turns out to be 1098240. So that's 1,098,240 different ways of having a pair. Amazing. Okay, so what's the trick to cards? What's the trick to doing these card problems? Breaking it down into decisions and choices, and always taking care of your condition first. Okay, those are my big tips to you on these. Okay, hopefully this gets you started, and I promise you're going to have questions. Make sure you ask your teacher for help on some of the tricky problems you're going to run into. All right, best of luck.